Hello everyone. In this session, I will continue to share with you the example of the application of Laplace transform in electrical circuit system using the first approach that is solved in differential equation, then Laplace transform. Now let's look at the example. By using suitable method or theorems, show that the inverse Laplace transform of 1 over s in the bracket s plus 10 is equal to 1 over 10 in the bracket 1 minus exponent minus 10t. In order to solve this denominator, we can solve it using in the form of partial fraction. So therefore 1 over s times the s plus 10 is equal to a over s plus b over s plus 10. Okay, so this one we in the partial fraction form. Alright, so next is 1. So this one will bring to the right hand side. 1 equal to a s plus 10. We cancel out the s plus b s. We cancel out the s plus 10. So then let the s equal to 0. A equal to 1 over s plus 10. This is equal to 1 over 10. Then let the s equal to minus 10. So this is equal to 1 equal to b minus 10. So b is equal to negative 1 over 10. Now inverse Laplace transform of 1 over s plus 10 equal to 1 over 10. Okay, a is 1 over 10. Then inverse Laplace transform of 1 over s. We substitute the a and b. Okay, b is minus 1 over 10. Inverse Laplace transform of 1 over s plus 10. So from table of Laplace transform, we know that inverse Laplace transform of 1 over s is equal to 1. Where s inverse Laplace transform of 1 over s plus 10 is equal to exponent minus 10t. And so this is equal to 1 over 10. We can take out the 1 over 10 and we simplify into 1 minus exponent minus 10t. Okay? So we get this answer and it is the same with the question 1 over 10, 1 minus exponent minus 10t. So we can prove the question. Or alternatively, we can solve using another method. So this is by completing the square. So s over s plus 10. This is equal to s squared plus 10s. So the question asks you to find the inverse Laplace transform of 1 over s plus 10. Okay, so s squared plus 10s. Okay, how to get the 10s here? 10s, we can factorize it, such as the s plus 5 and s plus 5. We can get s squared plus 10s. But the 5 times with 5, we can get the 25. But in the question, we don't need the 25. But in the factorization, we have the extra of 25. Therefore, we need to minus with 25. Because this is extra. Okay, so this is an extra. So therefore, I can write in this way. S plus 5 squared minus 25. So inverse Laplace transform of 1 over s plus 10 equal to inverse Laplace transform of 1 over s plus 5 square minus 5 square. Okay, if we look at this one we can change it to the exponent minus 5t. This one we can change to exponent minus 5t based on the table of Laplace transform. Okay, if you look at this form, actually is referred to is a minus, is referred to a sinh. Because if we look at sinh, at is equal to a over s squared minus a squared. So it's more or less like this form, s squared minus 5 squared So this is the A. So this one must be multiplied with 5. So therefore, you have the 5 here. We must cancel out the 5 by divide it by the 1 over 5. Okay. Then s plus 5, we can change it to exponent negative 5t. And then inverse Laplace transform of 5 s squared minus 5 squared. So this one, we can solve it using inverse Laplace transform of sinh. So we get sinh 5t. So sinh also can change it. You can solve it because the first part is the exponent. We can solve it. So sinh at actually is equal to exponent at minus exponent minus at divided by 2. So we can substitute in. So 1 over 5 exponent minus 5t exponent 5t minus exponent negative 5t divided by 2. So this is equal to 1 over 10, 1 minus exponent minus 10t. So this answer, we also, using this method, you also can get the same answer like given in the question. You also can prove. So there's many ways to solve the question. Or alternatively, we can use transform of integrals. So we use transform of integral, in which the transform of integral formula is inverse Laplace transform of fs over s. Then you could get 0 to integration 0 into infinity f tau d tau. So based on the question, that is the inverse Laplace transform of 1 over s times with the s plus 10. So if you compare with this transform of integral formula, easily you can detect that 1 over s plus 10, that is refer to the fs. Okay, so therefore we can use this formula. So that is equal to integration 0 to t. So fs, okay, f tau means that this is the fs. So inverse Laplace transform of 1 over s plus 10 is equal to exponent minus 10 tau d tau. So you integrate exponent negative 10 tau, you get exponent negative 10 tau divided by negative 10. The integration from 0 to t. You substitute the tau with t, so you get exponent negative t divided by negative 10 minus with exponent 0 divided by negative 10. And so you get, okay, this is the positive. So you get, this is 1 minus exponent negative 10 t divided by 10, which is also can prove the result you obtain from here, same as the question given. Alright. So that is how we solve the problem of the Laplace transform. We can use many other ways to solve this, that which one is more suitable. Next, we go to a second question. Find the inverse Laplace transform of exponent negative 2s divided by s plus 10 equal to 1 over 10 multiplied with 1 minus exponent minus 10 t minus 2 u t minus 2. Okay, by following the second shift theorem procedure, we know that the first step is to find the a. A is referred to here. Okay, a is equal to 2. So this 2 is referred to the a. Then second is to find the fs. So fs of this question is 1 over s times with s plus 10. So you get 1 over s plus 10. And then we inverse Laplace transform of the fs, we get ft. So from part A, okay, from previous question, we know that the inverse Laplace transform of 1 over s times with the s plus 10 is equal to 1 over s 1 minus exponent minus 10t. So step number 4, from the ft, t we substitute with the ft minus a. Here we can get 1 over 10, 1 minus exponent minus 10, t minus 2. And step number 5 is inverse Laplace transform of this whole equation. We can get 1 over 10, 1 minus exponent minus 10, t minus 2. Then the last step 5 is we top up with the u t minus 2. This u t minus 2 we should follow the t here. If t minus 10, we also have t minus 10. Alright. Next we move to another question that is suppose that the capacitor C in the circuit of figure beside has a 0 initial charge Q0 equal to 0 and there is no initial current I0 equal to 0. At time t more than 0 second, the switch is drawn from the positive B to A, held there for 2 seconds, then switch back to B. Given that C is equal to 0.1 farad, R is equal to 1 ohm, and the power source of 4 watt is applied to the circuit. First of all, write the source voltage ET in the form of step function. So based on the information given in the question, we know that we can write down the source voltage, okay, ET is equal to 4 for t 0 to 2. This is because it says that the switch is drawn from B to A. This means that its initial is B to A. So there's when switch to A means there is a 4 volt. Then held for there for 2 seconds means that it is 0 to 2 only. And then switch back to B. So means that after that there is no more voltage. So it's 0 for t more than or equal to 0. Right? Second question, change the step function in part B to unit step function. Okay, change the step function means that we change this step function to unit step function. Here we can have the ET equal to 4 plus, okay, 0 minus 4. Okay, 0 minus 4 for unit step t minus 2. So we rewrite into 4 minus 4 unit step t minus 2. And then the third question, by applying Kirchhoff voltage law, show that the circuit is governed by dqt plus 10q plus equal to 4 minus 4ut minus 2, in where the it is dqt over dt and integration it dt is equal to qt. This means that we need to find the voltage drop. In question 3, this means that we need to find the voltage drop across the resistor plus the voltage drop across the capacitor equal to the ET. So voltage drop across the resistor is ITR plus the voltage drop across the capacitor is 1 over C integration 0 to t it dt equal to 4 minus 4 u t minus 2. Okay, from the question given, we already know that the it is referred to this one, dqt over dt. So we can substitute in the it like this. So dqt over dt plus with, okay, integration of it dt equal to qt. This means that this part we will substitute this one. And this part will be substituted by this. So I can have the qt over c, which is equal to 4 minus 4 ut minus 2. So r is equal to 1 and c is equal to 0.1. So substitute in the r and the c here. So I get dqt over dt plus with qt over 0.1. That is, we obtain 10 qt equal to 4 minus 4 ut minus 2. And the answer is proof that we get the same answer. And then the last question is to solve the differential equation in part B3 by applying the Laplace transform. So applying the Laplace transform, this means that the Laplace transform of the dqt over dt plus with 10 Laplace transform of the qt equal to the Laplace transform of 4 minus 4 Laplace transform of the ut minus 2. Via the Laplace transform of derivative, we can change this one to s qs minus q0. Okay, and then this one to plus 10qs equal to Laplace transform of 4, you get 4 over s, and Laplace transform of ut minus 2, you can get s power negative 2s divided by s. Okay, and then given in the equation q0 equal to 0, so we can get s, okay, this one is 0, so s plus 10 qs equal to 4 over s minus 4 s power negative 2s divided by s. And then qs is equal to 4 divided by s, and then divide by s plus 10. And this one also the same, 4 s power negative 2s divided by s, and then time with the s plus 10. So we inverse Laplace transform of the qs. We can obtain 4 inverse Laplace transform of 1 over s plus 10 minus 4 inverse Laplace transform of the s power negative 2s divided by s times with the s plus 10. Okay, so this part inverse Laplace transform of 1 over s times with the s plus 10, we obtain from the answer in part A1, we obtain 1 minus s1 minus 10t divided by 10. So similarly to this part, s1 negative 2s divided by s over s plus 10. And this one we get 1 over exponent negative 10 t minus 2 ut minus 2 divided by 10. So we can simplify this one, we get 5, we want to get 2, so 2 over 5, 1 minus exponent negative 10t. This one also the same, 2 over 5, multiply with 1 minus exponent negative 10, t minus 2, multiply with ut minus 2. Okay, so that's all for this question. The question is quite long. And the answer also, you have a few methods to solve it. Depends on your understanding which method you want to use. However, if the question requests you to find using some particular methods, then you need to follow based on the question given. Okay, that's all for today. Hope you can understand, and thank you for watching.